Hello students, in today's session laws of motion, further basics will be clear through illustrations taken from JEE Main previous year questions. In today's session we are going to discuss dynamics of circular motion, friction and Lami's theorem. Lami's theorem. As the session is going to be very important, it is requested go through the session completely. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि वी हैव गॉन थ्रू ऑल दीज विच यू कैन रिव्यू ऑन यूट्यूब चैनल SethiSwiftLearn एंड वेबसाइट SethiSwiftLearn.com. इसी के साथ साथ एक रिक्वेस्ट और है कि अगर अभी तक आपने यूट्यूब चैनल सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट and share with your colleagues and friends. Now let's start with the question and concepts. Question is, a body of mass 1 kg is suspended with the help of two strings making angle as shown in the figure. This is the figure. Magnitude tension T1 and T2 respectively are in Newton. Take acceleration due to gravity 10 meter per second square. 4 options are given to you. One of the options is correct. Question is taken from JEE Main 2025. Concept, applicable and solution. Equilibrium of concurrent forces. Lami's theorem. Lami's theorem, which states that if three coplanar concurrent non-collinear forces acting at a point are in equilibrium, then each force is proportional to the sign of the angle between the other two forces. It is expressed as this one. Suppose this is the point. Three forces are acting like this, like this, like this. Then in equilibrium, F1 upon sin alpha, this is F1 sin alpha, F2 upon sin beta, F3 upon sin gamma. These are. It means if three forces are acting at a point and is in system is equilibrium, point is in equilibrium, means तीन forces, तीन लोग एक चीज को खींच रहे हैं, कोई इधर कोई इधर कोई इधर, but it is not moving. In that case, equilibrium is there and this factor is applicable here. This theorem is applicable here. That is known as Lami's theorem. Now let's apply the Lami's theorem to the question. Now applying Lami's theorem to the question. Question I will reproduce here. This is one force is T1, one force is T2, another is T2. Wait. Three forces and this is equilibrium. This body is mass 1 kg. Three forces are acting on it and system mass is in equilibrium. In that case, T1, T2 mg. T1 over T2 over mg over T1 के opposite angle क्या है? T1 के opposite angle between these two means this is 90 degree, 90 plus 30 120 degree, 90 plus 30 120 degree, sin 120 degree. T2 क्या है? T2 ये आ गया. T2 comes out to be 90 plus 60 150. This is 90 plus 60 sin 150 degree. And mg, weight mg equal to, this is 180 linear, so 90 to this comes out to be 90 degree. So sin 90 degree. Right? Now T1 over sin 60, sin 120. Second quadrant sin 120 की वैल्यू कितनी आ जाएगी? Sin 180 minus 60, that is sin 60. That comes out to be 2 upon root 3. 2 upon root 3. Root 3 by 2 equal to T2 upon sin 150. Sin 150, that is sin 180 minus 30, that is sin 30, that is 1 by 2. 1 by 2 means twice T upon equal to mg. 1 into g, divided by sin 90 1. So T1 comes out to be G upon 1 into root 3 upon 2, that is 10 by 2 root 3, that is 5 root 3 Newton. T1 is this one. T1 is this one. And T2 will come out to be G by 2, that is 10 by 2, that is 5 Newton. This is T2, this is T1. Let's check the answer. 5 root 3 and A is the correct answer. Right? Next question. Question is, a body mass M is suspended by two strings making angle theta 1 and theta 2 with the horizontal ceilings with tensions T1 and T2 simultaneously. T1 T2 are related by T1 equal to root 3 T2. The angle theta and theta 2 are. Four options are given to you. One of the option is correct. Question is taken from JEE Main 2025. Concept applicable. In this question also, equilibrium concurrent forces. Concurrent forces with three forces acting at a point, at a body, and object, point object, and the object is in equilibrium. In that case, F1 upon sin alpha, F1 के अपोजिट एंगल क्या है? दो फोर्सेस के बीच अल्फा, F2 के अपोजिट बीटा, F इक्वल गामा. तो F1 upon F2, F1 upon sin alpha equal to F2 equal to sin beta equal to F3 upon sin gamma. This Lami theorem is applicable in this case also. Now, this is ceiling. This is ceiling. So this is parallel to this horizontal line, right? This is 90 degree. Weight at 40 degree down. Applying Lami's theorem at point A. So this point is A. At point A. It is applicable at a point also where three forces are acting on that point. So T1 upon T2 upon mg upon. Now total gamage of angle T1. T1 के अपोजिट क्या है? ये एंगल क्या आएगा? थीटा 1. दिस एंगल वुड बी, ये एंगल है, दिस एंगल वुड बी थीटा 2. T1 के अपोजिट साइन 90 प्लस थीटा 2. 90 plus theta 2. This is 90. T2 के अगेंस्ट this comes out to be, this will be alternate angle theta 1 sin 90 plus theta 1 equal to mg. This comes out to be sin 180 minus theta 1 plus theta 2. On simplification we get T1 over cos theta 2 equal to T2 upon cos theta 1 equal to mg upon sin theta 1 plus sin theta 2. Now further calculation. On simplification, we are taking this according to question T1 equal to root 3 T2. T1 equal to root 3 T2. According to question T2. So substituting here root 3 T2 upon cos theta 2 equal to T2 upon cos theta 1. इसको सिंप्लीफाई करें, T2 T2 कैंसिल होगा, तो रूट 3 cos theta 1 equal to cos theta 2, that is root 3 cos theta 1 minus cos theta 2 equal to 0, right? Now, according to question, 30 degree and 60 degree are the possible answers. So by common sense, theta 1 we can take 60 degree. 60 degree, theta 2 we can take 30 degrees. Cos root 3 by into 1 by 2 minus root 3 by 2. Purpose is solved. So theta 1 equal to 60 degrees, theta 2, and we have to find T1 or T2. T2. To find T2, we are considering this and this. T2 upon cos theta 1. Cos theta 1 is cos 60 degree equal to mg upon sin 30 degree plus sin 60 degree, that is mg, sin 90 degree, that is mg upon 1. Cos 61. So T2 equal to mg cos 60, that is mg into 1 by 2, that is mg by 2 Newton. So these are the answers. 60, 30 mg by 2. C is the correct option. C is correct option. C is correct option. Right? Next question. Question is, a cubic block of mass m is sliding down on an inclined plane at 60 degree with an acceleration of g by 2. The value of coefficient of kinetic friction is, value of acceleration be given over. This is the body of mass m. Weight acts vertically downward and reaction acts like this. Reaction acts like this. So resolving this weight into two parts. This is theta, mg cos theta, and this force mg sin theta, and it is sliding down. The friction force will be acting in this direction, mu mg cos theta, This will be the friction force. Now, according to free body diagram, theta is mg sin theta. This acts always downward because the motion in this direction or acceleration is equal to given as g by 2. Net force along the inclined plane equal to mass of body under consideration. Body to body defend करेगा ये into acceleration. Because no vertical motion is there, so this force will be equal to this force. Vertical forces will be balanced. So mg sin theta minus mu mg cos theta. Because the motion in this direction, this is dominating than this. That is equal to m into a. M से m कट गया. G sin 60 degree, theta is 60 degree. Sin 60 degree minus mu G cos 60 degree equal to a g by 2. Acceleration is g by 2. A is g by 2. G cancel हो गया. Root 3 by 2 minus mu 1 by 2 equal to 1 by 2. 2 भी cancel हो गया. Root 3 minus mu equal to 1. Mu comes out to be root 3 minus 1 simplified. This is the answer. Let's see, check the answer. C is the correct answer. C option is the correct answer. C is correct answer. Right? Next question. Question is, the car of mass m moves on a banked road having radius r and banking angle theta. To avoid slipping from a banked road, the maximum permissible speed of the car is v0. The coefficient of friction is mu between the wheels of the car and the banked road. is, four options are given to, one of the option is correct. Question is taken from JEE Main 2025. Concept applicable in solution. Dynamics of circular motion. This is the rod. This is the banking angle. That is, rod is not horizontal, it is slightly sloped, right? Now in that case, weight acts vertically downward and reaction is always perpendicular to the surface. This is the perpendicular. Resolving this R into two parts, R cos theta, R sin theta. And similarly, this is the friction force. Resolving this force into two parts. One is, this angle is theta, this F sin theta and F cos theta. Right? Now, resolving forces horizontally and vertically. Resolving forces horizontally and vertically. Right? If we talk about this one, horizontal, then R sin theta plus, this will come out to be F cos theta equal to, it is not a horizontal acceleration, this is a circular acceleration. Centripetal acceleration is m, maximum speed allowed is v naught square by r. R is the radius of the circle path, the circle banega, right? This is equation 1. And vertical motion में क्या होगा? It is not moving upward vertically, so upward forces will be equal to the downward forces. Downward forces क्या act कर रहे हैं? Weight act कर रहा है plus F sin theta act कर रहा है, that is equal to R cos theta. That is R cos theta minus F sin theta equal to M into G. This is equation 1. Now dividing 1 by 2. So 1 divided by 2, this comes out to be R sin theta plus F cos theta divided by R cos theta minus F sin theta equal to mm कट जाएगा, v naught square by rg. Right? Now on further calculation. Now as F equal to mu r, friction force equal to mu r is the coefficient of friction, then R is R cos theta plus R sin theta plus mu r cos theta upon R cos theta minus mu r sin theta equal to v naught square by gr. Right? R cancel हो गया, dividing numerator denominator by 10 cos theta. Because in the answer 10 theta is given to you, we have to divide it. R cancel हो गया, cos theta से divide किया बचा ये 10 theta plus mu upon cos theta से divide किया 1 minus mu tan theta equal to v naught square by gr. इसको सिंप्लीफाई कर देते हैं, gr tan theta plus mu gr equal to v naught square minus v naught square mu tan theta. अब हमें रिक्वायरमेंट है mu कॉमन ले लिया, gr plus v naught square tan theta इक्वल टू, इसको इधर शिफ्ट किया, इधर जाए v naught square minus gr tan theta. So mu comes out to be v naught square minus gr tan theta upon v naught square tan theta plus gr. This comes out to be the coefficient of static friction. On simplification, this comes out to be V naught square RG tan theta minus RG V naught square tan theta plus GR इसका. B is the correct answer. B is the correct option. B option is correct option. Right? Now, I would like to request, if you are new to my YouTube channel, SethiSwiftLearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.